Let's look at exponents converting to prime bases. So if we are given the value of 4, if we need to convert this to a prime base, we know that 4 is 2 times 2, which can be written as 2 to the power 2 or 2 squared. If we look at 18, 18 can be written as 2 times 9 here. 2 we leave the same, but 9 we know can be further simplified into 3 times 3. So to write as prime bases, 18 can be written as 2 to the power 1 times 3 to the power 2. Okay, let's look at separating exponents. So if we have 2 to the power x plus 1, and we need to separate these exponents, you will need to learn how to do this later on for algebraic fractions, so let's learn how to do this now. Separating exponents. So we have 2 to the power x plus 1. This can be separated into 2 as your base to the power x times 2 as your base to the power 1. So 2 to the power x times 2 to the power 1. Let's look at the next one. 5 to the power 2x plus 1 similarly can be separated as 5 to the power 2x times 5 to the power of 1. Let's simplify exponents in fractions. So if we are given negative 8x to the power 5y all over 2x squared y, let's simplify this. Let's look at our constants first. We have negative 8 in your numerator and we have 2 in your denominator. So because this is a division sign here, negative 8 divided by 2 gives me negative 4. So my coefficients are sorted out. Now let's look at the variables. First we look to see if there are any variables that can cancel off. Remember, you can cancel variables that are exactly the same in the numerator and the denominator. So we have y on the top and we have y at the bottom. We can cancel those out because this is all one term each on the top and bottom. So we will be left with then our x bases. We have 5 on the top, 2 at the bottom. Remember in a fraction that the center line means divide. So remember the rule for when you're dividing powers with the same bases, you need to subtract the exponents. So that would become x to the power 5 minus 2. So our final answer then would be negative 4x to the power of 3. Okay, another example, 3 to the power x plus 3 to the power x minus 1 all over 3 to the power x. Now, you need to realize that these two terms here, 3 to the power x in the numerator and this 3 to the power x in the denominator, cannot cancel off. Now, the reason they cannot cancel is because the top here has 2 terms. So because there are 2 terms in the numerator, we cannot cancel anything from the numerator and the denominator as it stands. So what we will need to do is we will need to first separate our exponents. So see, we have not cancelled our 3 to the power x on the top and bottom here. But what we will do is we will separate the second term on the top. So 3 to the power x minus 1 will become 3 to the power x times 3 to the power negative 1. Now we need to look for a common factor on the top. We have 2 terms in the numerator. Common factor to the first term and to the second term is 3 to the power x, if you can see that. So our common factor is 3 to the power x. If we pull that out, 3 to the power x times what will give me my first term on the top, 3 to the power x, that's going to be 1. Then for my second term here, 3 to the power x times what will give me 3 to the power x times 3 to the power negative 1, that's going to be 3 to the power negative 1 here. All over 3 to the power x, my denominator. Now, because I've pulled out my common factor, I can cancel off my 3 to the power x on the top and the bottom. I'm left with 1 plus 3 to the power negative 1, and that is actually 1 1/3.